Good morning, everyone. Welcome to today's webinar from Radiocrafts. Good morning, Armando. Hi. Shetil, hello. Good morning. Um, okay, so we're waiting for more people to join. Meanwhile, on behalf of Radiocrafts team, I would like to thank you all for taking the time to join us this morning. Hope you're having a fantastic day wherever you are. Hope you have your coffee cup ready with you. My name is Omar, and I'll be presenting today's webinar, which is titled State-of-the-Art IP Mesh for State-of-the-Art Street Lighting. Um, as you have probably already guessed, in today's webinar, we will be focusing on the new and novel features of our new RIIM, RIIM 2.0, and how these features directly address the critical and most common demands of street lighting networks, and how RIIM 2.0 will surely help you create a modern street lighting, which is many, I would say, light years ahead than your closest competitor. So by the time I'm done with my funny jokes, hopefully everyone is here. Okay, let's start. As always, we try to keep it short and simple. So today's webinar is scheduled for approximately 30 minutes, and we will try to keep 15 minutes at the end to have a short Q&A session. So as you are doing, keep the good habit, and please feel free to introduce yourself in the chat window. Also, feel free to write down any questions you might have in the chat window, and we will answer them as soon as the presentation finishes. And by the way, this webinar is being recorded, and you can, of course, check the video later on our website and also get the presentation slides. So if you miss a part, don't worry about that. So without further ado, let's move on to today's agenda. We will start, as always, with a very brief reminder of RIIM and its most relevant features for today's topic. Then we will briefly explain why smart street lighting networks are important. And then we will give you insight into data we collected through hundreds of hours of speaking to our street lighting customers. And we will understand from them what are the most common difficulties that they face with street lighting. And then we will see how our R&D team kept these challenges in mind while developing RIIM 2.0 and how its features directly solve these challenges. So very briefly, since we mentioned this some times before, in case someone is this is his first webinar. So RIIM is Radiocrafts' unique end-to-end IP mesh network. It's designed mainly for massive IT, industrial IT, and smart city IT networks. 20 years of experience in the RF domain were put into developing RIIM to be an enabler to a wide variety of use cases. Our expertise is reflected in how versatile RIIM is. Firstly, it operates in sub-1 GHz bands for license-free and long-range operation. The main supported bands are around 868 and 915 MHz, and you can also contact us through one of our emails to get more information about 433 MHz support. So briefly, RIIM supports two modes of operation, single channel and TISH, each with its own advantages and optimum use cases. RIIM also supports multiple layers of security, such as DTLS. On the application layer, RIIM supports both CoAP and UDP. A single RIM border router can support up to 1,000 nodes with the ability to send multicast messages as well. As for range, actually, let's speak about range when we get to it. So this is RIM in a nutshell, very briefly. So why is smart street lighting important? Street lighting, I mean, the old style networks, they're responsible for around 1/5 of the electricity usage around the world. In a city level, if you take one city, street lighting is responsible for up to half of a typical city's electricity usage. As you can imagine, that's a lot of carbon dioxide emissions. But the good news is this is very much avoidable when switching to smart street lighting solutions, as we will see shortly. But also, the benefits of using smart street lighting solutions do not only end here. There are also benefits of having a smart network, such as setting automatic lighting and dimming plans, setting the light intensity to change in accordance to sunlight available, and so on. Another thing is also the lighting technology itself. Smart street lighting uses LED lights, which offer significant advantages over conventional lamps, such as brighter nighttime visibility, less light spillage, and so on. And actually, according to a paper I was just reading a few hours ago from the latest global trial of LED streetlights, it shows that LED fixtures can deliver electricity savings of up to 80% over the classical lighting technology. I mean, if you just look at this picture, the picture on the on the right is the classical lighting lamp, and on the one on the left is the LED. So it's brighter, you can see more, it's safer, it's more comfortable, and it saves up to 80% more power. So how does one create a successful street lighting network, or what are the parameters needed or the requirements for such a network? Of course, range comes on the top, high throughput and two-way communications. Time synchronous events, ease of integration with cellular modems, reliability of the communications, the ease of cloud integration, and then something called real-time adaptive lighting, which we will speak about in the end of the presentation. So range is one of the key differentiating parameters when it comes to street lighting networks for a number of reasons. First, street lighting networks obviously are designed to cover very large areas, mainly cities. So of course, large coverage area is a must here. Second, by their nature, street lighting networks are deployed in environments where it's very usual to have obstacles in between communicating nodes, such as trees, buildings, and so on. Okay, so how does RIM rank when it comes to range? According to our internal tests, RIM high-power modules can reach line-of-sight ranges of more than 10 kilometers when using the maximum output power of 27 dBm. Then when you couple that with RIM's ability to accommodate up to 28 hops, you can very easily cover a whole city with one RIM network. As cool as this sounds, I bet it sounds even cooler when you see it in light of LoRa, for example, which can hardly reach a maximum range of 3 kilometers on the lowest possible data rate, which is nearly impractical to send any kind of data on, let alone sending over-the-air updates, for example. RIM range doesn't only dwarf LoRa, also another technology which has for long been mentioned as a possible enabler for street lighting is 2.4 gigahertz mesh networks like Zigbee Mesh, for example. It's true they might have some advantages of being a mesh network, but the fact that they operate on the free ISM band, the 2.4 gigahertz band, makes the range always inferior to RIM, which operates on sub 1 gigahertz, due to, of course, the increased interference on the 2.4 gigahertz band and increased signal attenuation, especially between common obstacles in streets, such as trees, for example, due to their water content. Okay, so how does RIM provide high throughput? Despite the fact that we engineers don't like duty cycle and spectrum access regulations, they are actually pretty important to allow for a fair distribution of radio frequency use. Though they kind of tie your hands as a radio user and restrict how much use you can squeeze out of your allowed spectrum. Duty cycle refers to the time your radio is allowed to transmit in. In Europe, for example, under ETSI regulations, a radio's maximum duty cycle is 1%, which means that the radio is only allowed to transmit in 1% of the time. So this translates to only 36 seconds in one whole hour. So how does RIM manage to squeeze out more throughput in such tight restrictions? And what benefit does this give to street lighting networks? Let's see. As I always say, our main goal is to always make your lives easier. And that's why in RIM 2.0, we started using a technique called polite spectrum access. Very simply, it can be broken down into two main components: listen before talk, it's also known as clear channel assessment, and adaptive frequency agility. Listen before talk works just as its name implies. The radio scans the 14 available channels in Europe before transmitting on any of them. If a channel is found to be noisy, the radio waits and doesn't transmit on it. This hugely increases the radio's resilience to noise, which directly reflects on the packet error rate, which just boosts the network performance. On the other hand, we have adaptive frequency agility, which works on top of listen before talk by marking the channels which are often found to be noisy. Then it drops those channels from the hopping list, which ensures that the radio only uses the channels with the least noise. Okay, so what use is this polite spectrum access? Well, according to ETSI regulations, a radio implementing polite spectrum access can increase the time it can utilize a single channel from 1% to 2.7%. Multiplied by 14 channels RIM uses in Europe, this means that the whole system's duty cycle is now 37.8%, which is absolutely amazing. Just imagine what you can do with 37 times more time on air than the system you can be using now. So obviously this brings much benefits, as increasing duty cycle by such a huge margin makes over-the-air updates easier, frequent transmissions easier, lamp status monitoring easier, and more efficient and faster. And of course, implementing such noise sensing techniques ensures that noisy channels are avoided, which significantly reduces packet error rates and allows for more range per hop, so more range in general. Why I believe RIM is far from its competitors is exactly this point. While RIM, for example, can allow up to nearly 40% duty cycle, other technologies such as LoRa, for example, is not even real two-way communication technology, meaning its downlink is very slow, making it maybe more suitable for sensor deployments in a field where traffic profile is mainly uplink dominated. There isn't much need for much downlink. But when it comes to street lighting, downlink is also very important, as it's some sort of a control network. You might need to send new lighting schedules, new firmware, and so on. Which really makes this increase in the allowed data throughput a golden feature for street lighting. And now for my personal favorite feature, time synchronization. So what does time synchronization actually do? Maybe to understand it well, it's better to look at how life would be without it. Well, let's say time synchronization doesn't exist, and you want to start a certain event in your network at say 8 p.m. for example. You would then have a number of options. Maybe you can send the multicast at 5 minutes before 8 at 7:55, and just pray that the messages reach all nodes by 8. But then the message would reach every node at a certain time, dependent maybe on where it is in the mesh. And the event will start at different times all over the network, which can be a bit chaotic, especially if it's street lights. Then every pole will just light by itself. And the second option you might have is to connect a GPS module to each node, which isn't quite the best option, at least not financially. So how does time synchronization work? In normal dish operation, all nodes are synchronized in time. So to execute node processes in a synchronized manner, you have two options: to either synchronize them according to the real day time or according to an epoch timer. To make it even more versatile, a RIIM border router can receive timing information through several ways, either through co-op or through UDP, or even through non-radio means, such as UART or other serial connections. And how this is directly a very beneficial feature for street lighting is simply it gives you the ability to set street lights to turn their lights on and off automatically at certain times, and most importantly, in a synchronized manner. So you wouldn't have a network where each light pole just lights by itself. According to our understanding, several street lighting customers prefer to use cellular communications as means to route the data as a backhaul from their RIIM border router to the central management system. To achieve this, protocols must be interoperable. Therefore, our R&D team has developed a SLIP interface, which is now part of the new RIIM SDK 2.0. Very simply, SLIP takes radio packets reaching the border router and converts them to an IP over serial format, making them suitable to be transferred to a Linux device via UART. This is very important to maintain their IP version 6 format till they reach the Linux device, which then sends this data stream via Ethernet to a cellular modem. This way, IP version 6 can be maintained all the way, and that's very important for the following reason. It's very important to have end-to-end IP connectivity. As we said, RIIM natively supports cloud connections using IP version 6, which ensures end-to-end IP packets. Of course, this gives huge benefits when it comes to being future-proof, when it comes to achieving end-to-end security, where the packets are not translated to any other protocol in their mid of the journey. And of course, for global addressing. Real-time adaptive lighting. So, real-time adaptive lighting refers to some sort of edge intelligence that can be achieved in the light lamp itself. For example, in this picture, if a street is dark and then someone is passing by a certain light pole, this light pole needs to turn on its light, but it doesn't have to send the data all the way to the central management system and then get a command to turn on. This node can itself, and the nodes close to it, send a local multicast message to just this group and ask them to turn their lights on. So this way, you have a group of your light poles which executed a process without getting back to the central management system. So it's some sort of edge intelligence, which you can also improve yourself in the EC code, which significantly reduces the overall traffic between the nodes and the management system. It can also be very beneficial if in case of an increased traffic in a certain area or rain in certain parts of the city, road accidents, any circumstance that happens in a specific part, which only a specific number of light poles need to act on. So to summarize what we spoke about today, we spoke about the main features of RIIM 2.0, which make it suitable for street lighting. We discussed RIIM's high power. We said that it can reach more than 10 kilometers line of sight between one hop, and the RIIM can support up to 28 hops. We spoke about time synchronization and how we can have time synchronous events with RIIM. We spoke about real-time adaptive lighting and how a street lighting network with RIIM can be real-time adaptive and adapt itself to certain situations. Spoke about end-to-end IP version 6 connectivity and ease of integration with cellular modems using our SLIP interface, which is available in the new SDK. And of course, about the taking the duty cycle from 1% to 10 to 40% in European bands using polite spectrum access techniques such as listen before talk and adaptive frequency agility. So I see that you have some questions here, and will be helping me to answer the questions our R&D director, Rian.
Hello. Yes, my name is Arian Notvedt, and I will try to go through a bit of the questions that you posted. So thank you very much for the questions. I will start with Armando's about data integrity and authentication. Yes, of course, we have both integrity and authentication. We have 2 layers of security currently in RIIM. The first one is a network layer, which uses both encryption of packet and includes a MAC part or message authentication part of the packet, which is used for just accessing the network. And in addition, you have the opportunity to use end-to-end security by having DTLS, which allows you to have end-to-end security between the transmitter and receiver. So that means the mesh routers in between and anybody in the between will not be able to, even though they're part of the network, will not be able to get hold of the packet content. Why I will just follow up by taking Armando's second question about the digital certificates at each leaf nodes. So currently, with the current solution is not based on digital certificates, but that's something we are looking into for future releases. It is an option on our drawing board. So I guess you have to follow and see what happens there. Currently, it's pre-configured fixed keys on all leaf nodes, which is the solution. Then we can move over to Magnus' question, talking about replacing Zigbee. Yes, so it's kind of a easy question. If we think RIIM is good for buildings, yes, definitely. We have tested it in building systems. Is one of the key use cases of this as well. And the advantage, of course, is the range. So in Zigbee, you need more devices, and it's shorter range between each. But with RIIM, you can probably have like twice the range indoor, which compared to Zigbee. Magnus also asked about sleeping devices, battery drain. Can you broadcast messages to sleeping devices? how often do sleeping devices poll their parents? So basically, the polling is something the user can configure. So because this is not so you can choose to poll every second or 2 seconds, or you can poll every hour if you want to. So that again depends on the use case, how much battery you have, and what type of latency requirement you have in each use case. The current consumption in the sleeping nodes, when they just are awake, sometimes just keeping the network connections, making sure their parent is there and these kind of things, that is at 4.7 microamp. And then if you then later want to send some sensor data, then you have to, I think sending a co-op message up like every half an hour is something like 1 microamp in addition, or something like that. And then of course, if you poll every 10 seconds, that will increase. As we are operating at 50 kilobit, and compared to Zigbee, which is 250 kilobit, we do have that every operation, transmission, reception is basically 5 times as long as Zigbee. So that is that's what you want to. You have to consider that as well. What about 10, and how much output power can you require for 10 kilometers? Well, for 10 kilometers, obviously you have. It depends on what kind of environment you have between the two nodes. If you're talking, I hope you're talking about a pretty open area with line of sight. For 10 kilometer, I would definitely say it's a high power module. I don't think the low power modules would be very suited for 10 kilometers. And I would say that the 10 kilometers, I would say that then like a normal monopole whip antenna is would be a good solution with a proper ground plane. But I guess that so I think you need a pretty good antenna to reach 10 kilometers. It also depends. The 10 kilometer also depends on the background noise. So 10 kilometers is kind of, I know it's 10 kilometers is very much like I wouldn't say marketing term, because we can reach 10 kilometer, but it always depends on the environment and stuff like that. We know that, for instance, in Oslo Centrum, where we are, and also we see other places around the world, there's quite a lot of background noise that we see, for instance, in India and stuff like that as well. So depending on if you're in the rural area or urban area, it would also affect the background noise and stuff like that. So it's a bit complicated question. So it's not like the antenna and then you have 10 kilometers. It all depends on the line of sight and stuff like that as well. But we can have a discussion on that, Kjetil, if you need to. RIIM for solar street lighting. Thank you for that question, Joseph, because I thought we should mention it in the presentation, but I forgot to put that in. Because yes, definitely RIIM is very interesting for solar power streetlights, because with RIIM, when we have the TISH, it is we are turning off the radio when we don't need to. So we're just turning on the radio at certain time slots when we can expect the packet. That means we are on the average using, even if the highest power modes, we are using like 1%, less than 1 milliamp power consumption. And that is very good, of course, because that allows the customers that wants to do solar power street lighting. They are very concerned with power consumptions during the day. They don't want to waste any power. So I think it's very well suited for solar powered because of the street lighting, because of the low general power consumption. Yes, the kits are at the DigiKey. Both high power and normal powers RIIM kits are, I believe, on the shelf at DigiKey. So if you just Google search for RIIM inside DigiKey, I think you will find them. what output power we recommend for buildings. What we have seen is that the normal, we have tested it in this building we are located in. We saw that it's like 200 meters long or something, and 6 floors, an old concrete building in Oslo. And we see that with the 2 hops, we can basically cover the entire building. So we put up two routers in the middle of the building, and we cover the entire building very well. And that was done with a standard 14 dBm module. So the low power version, what we call the low power version. So that is again, if you have then we reached like 40 meters indoors typically, and then we have up and down some floors as well in those 40 meters. So again, it depends on use case. If you have 2 sensors in one huge building, obviously you need high power. But if you have again, it depends a bit on what the distance between the nodes are. So yeah. And the Q&A antennas. Yeah, we have an I think we have an application notes on antennas, but antennas is not black and white. It's always shades of gray, I would say, because it's always a trade-off between design, practical use of the product, and range, of course. And we normally recommend having the best solution is to have external antennas, WIP antennas, either dipole or monopole. But in many cases, customers choose otherwise because of design reasons, I would say. So it's not a one-to-one that's saying you have to use this antenna. I think customers have to understand their business case. Specifically, how important is the design, how important is the range, and these kind of things, and then how big is their product, stuff like that, and then we can discuss and suggest antennas based on their specific use case. But yes, we have an application notes as antennas as well, but that kind of outlines all the options you have. It doesn't tell you exactly what antenna solution to use. Okay. I think I covered covered a lot of the yeah, I think that covers a lot of the questions. I see Magnus says PCB antenna is almost as good as the external. Yeah, so you can use a PCB antenna. Of course, PCB antenna at 868 will be larger than 2.4. So typically it goes from 2.7 centimeter wire until 8.2 centimeter, I believe. So that means it all depends again on the space requirements you have on your product. But please, you can contact our support, Magnus, and you will be in contact with me and Omar, and we can look into the case specifically together with you. Okay. So I think that concludes the presentation. So thank you very much for giving this presentation, Omar.
Thank you, Ørjan. So always remember, you can reach us at support@radiocrafts.com to ask more technical questions, and sales@radiocrafts.com. And thank you all for joining us today, and wish you have a good day. Bye-bye.